Hello viewers, welcome to my channel. I am Hashim Ali Khan. So this is the last and final video on problems on Z test. So already I have completed 9 problems. 10th problem also we have done. 10th problem also we have done in the earlier videos. Now last 2 problems are left, that is 11th and 12th. So in this video I am going to finish off the problems on Z test. Remember, you have to watch in continuity one video then another video. If you come and join in between, you will not be able to understand. So my suggestion to you, if you want the perfect knowledge on this sampling, Z test, large sample test, watch all the videos. First watch 3 videos on theory, then the problems videos. So before starting the next 11th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep ready. Take a screenshot of the solution of 11th and 12th problem, then I'll explain all the points. Come on. See the 11th problem. In a random sample of 500 persons from Maharashtra, 200 are found to be consumers of vegetable oil. In another sample of 400 persons from Gujarat, 200 are found to be consumers of vegetable oil. So here 2 states are given. Maharashtra and Gujarat are the 2 different states in India. So we have taken a sample from Maharashtra and a sample from Gujarat. From Maharashtra we have taken 500 persons. Out of 500 persons, 200 are found to be consumers of vegetable oil. Same in Gujarat. In Gujarat we have taken a sample of 400 persons. In that 400 persons, 200 are found to be consumers of vegetable oil. So we are given the proportion of vegetable oil consumer in Maharashtra and proportion of vegetable oil consumer in Gujarat. Then discuss whether the data reveal a significant difference in between Maharashtra and Gujarat so far as the proportion of vegetable oil of consumer is concerned. Exactly similar to the problem we have done in the previous video. We are comparing the proportion of 2 samples. One sample in Maharashtra, another sample in Gujarat. So we calculate the proportion of consumers consuming vegetable oil. Now N1, how many persons we have selected in Maharashtra given in the problem? 500. And how many persons we have selected in Gujarat? 400. So in 500, how many are the consumer of vegetable oil? 200. It is given in the problem. So out of 500 persons selected, 200 are consumer of vegetable oil. So 200 by 500, it comes to 0.4. The proportion of vegetable oil consumer is 0.4 in Maharashtra. And what is the proportion of vegetable oil consumer in Gujarat? 200 divided by 400 is 0.5. So we got the proportion of vegetable oil consumer in Maharashtra and in Gujarat. We calculate P bar. P bar means the average of vegetable oil consumer in both the states combined together. Average. So P bar is equal to N1 P1 plus N2 P2 divided by N1 plus N2. Already this formula we have applied in the previous video. So N1, how much is N1? 500. 500 into 0.4 plus 400 into 0.5 divided by 500 plus 400. So 500 into 0.4, 200. 400 into 0.5, 200. So 400 divided by 900, 0.44. So 0.44 is the average consumer of vegetable oil in both the states combined together. P bar. So Q bar is equal to 1 minus P bar. 1 minus 0.44 is 0.56. We have calculated. Now we'll proceed on steps in hypothesis testing. The first step is laying down of hypothesis, null hypothesis. P1, capital P1, not small. Capital P1 means all the proportion of all consumers in Maharashtra. Proportion of consumers of vegetable oil in Maharashtra totally. And P2 is the total proportion of consumer of vegetable oil in Gujarat. So P P1 is equal to P2, P2 stands for proportion of vegetable oil consumer in Maharashtra and proportion of vegetable oil consumer in Gujarat, both are equal. Null means no difference. No difference in proportion. So here there is no significant difference in proportion of consumer of vegetable oil in Maharashtra and Gujarat. That is the null. Alternative hypothesis, exactly opposite, means there is significant difference. So P1 not equal to P2, two-tail test. When the sign not equal to is written, you should take two-tail test. Means rejection region will lie on both the sides, left tail as well as right tail of the normal curve. Now, there is significant difference in the proportion of consumers of vegetable oil in the two states. So here null hypothesis, no significant difference. Alternative, there is significant difference in the proportion of vegetable oil consumer in the two states. Now level of significance 0.05 assumed. It is not given in the problem. That's why we are making an assumption. Now test statistic. Since the samples are large under HO, the test statistic formula is this one. Already we have done in the previous video also. P1 minus P2. P1 minus P2 divided by P bar into Q bar into bracket 1 by N1 plus 1 by N2 under root. So P1 is 0.4, P2 is 0.5, 0.4 minus 0.5 minus 0.1 divided by P bar is 0.44. Here we have calculated somewhere, yeah, 0.44. Q bar is 0.56. Multiply both into 1 by N1. N1 is 500. 1 by 500 plus 1 by 400. So 0.4 minus 0.5 is minus 0.1. 0.44 into 0.56, 0.2464 into 1 divided by 500, 0.002, 1 divided by 400, 0.0025. Now numerator same, 0.2464, 0.002 plus 0.0025, you get 0.0045. You multiply these two, you will get 0.0011088 under root. So after root you are getting 0.0333. So 0.1 divided by 0.0333 you will get minus 3. So computed value of Z is minus 3. This will be compared with the critical value, table value of T, table value of Z. The table value of Z at 5% level for two-tail test is plus or minus 1.96. In so many problems I have explained you. You have to remember 1.96. How do you get 1.96? Watch my first and second video on Z table. Problems on Z test, first part and second part. If you watch that, you can be able to know I have explained. Plus or minus. Plus or minus when we should write when it is a two-tail test. When it's a two-tail test, plus or minus, because the rejection region will lie on left side as well as the right side. Left side minus, right side plus. So plus. So here our computed value is minus. So we compare with minus sign. So the critical region lies for Z less than equal to minus 1.96 and Z greater than equal to plus 1.96. Plus 1.96 से आगे और minus 1.96 से कम. That will come under critical region. Now decision. The computed value of Z is minus 3. Is less than the critical value of Z minus 1.96. If you compare, minus 3 is less than minus 1.96. So this falls in rejection region. This minus 3 will fall in rejection region. So null hypothesis is rejected. So if you want more clarity, I'll show it like this. See here. In this diagram, you can see here rejection region will lie on left side as well as on right side because it's a two-tail test. So here Z is minus 1.96, here Z is plus 1.96. So over plus 1.96 and below minus 1.96 will be in rejection region. Our computed value is minus 3. Computed value is minus 3. So here you can see minus 3 will lie somewhere here in rejection region. Minus 3 is less than minus 1.96. So it falls in rejection region. Our computed value minus 3 falls in rejection region. A rejection region means null hypothesis will be rejected. This null hypothesis is rejected. Then what is accepted? Alternative hypothesis accepted. What is here in alternative hypothesis? There is significant difference in the proportion of consumer of vegetable oil in the two states. That's what. HO is rejected. We conclude that there is significant difference in the proportion of consumers of vegetable oil in Maharashtra and Gujarat. That's it. So this is the end of problem number 11. The last and final problem, problem number 12. See carefully. The breaking strength of cables produced by manufacturer have a mean of 1800 pounds and standard deviation of 100 pounds. A company manufacturing cables. Now the company has tested and said that the average breaking strength of the cable is 1800 pounds. That means after 1800 pounds the cable may broke down, but the strength is up to 1800 pounds. Up to 1800 pounds it can bear the strength. Over 1800 it cannot bear. That is the contention of the company with a standard deviation of 100 pounds. By a new technique of manufacturing process, it is claimed that breaking strength will be increased. Now the company is introducing some new technology in the manufacturing, and the company claims that after introducing the new manufacturing process, the breaking strength will increase. Now the cable can bear more than 1800 pounds also. That is the claim of the company. To test this claim, a sample of 50 cables is tested, and it is found that the mean breaking strength is 1850 pounds. Can we support the claim at 0.01 level of significance? Now, after implementing this new technology process, the company has tested 50 cables, and this sample of 50 cables have shown the average breaking strength of 1850 pounds. Before that, the average breaking strength was 1800. So apparently it looks like that the breaking strength have increased. After the new process, the breaking strength have increased. Now we want to confirm whether definitely the breaking strength have increased or not increased. That is the problem. Right? So first of all, we write down the information given. Mu. Mu means population mean. Symbols. These symbols you have to remember, because every time we are writing the symbol, and in the first video I have explained you the population parameter and sample statistic. In that I have explained you that mu is the population mean and x bar is the sample mean. Sigma is the population standard deviation, small s is the sample standard deviation. Capital P is the population proportion and small p is the sample proportion. All these things I have explained in the first video. Same notation I am using. So mu is equal to population mean 1800 pounds given in the problem. Sigma is the population standard deviation 100 pounds given. N is equal to sample size. We have taken a sample of 50 cables. So 50. X bar sample mean. The 50 cable sample has given a mean of 1850 pounds. And alpha level of significance given in the problem 0.01. That's it. Now step 1. Null hypothesis. Null hypothesis, no significant difference between population mean and sample mean. Whatever the company claims, that is true. The company is claiming that the average breaking strength is 1800. So 1800 only. Mu is equal to 1800. There is no significant difference between population mean and sample mean. The claim that breaking strength has increased is incorrect. Company claims that breaking strength have increased. We are rejecting company claim. We are saying that the average breaking strength is same before introducing the new process and after introducing the new process. Now alternative hypothesis. But our sample shows more breaking strength. See here, the sample mean is 1850. 1850 is more than 1800. So right tail test, mu is greater than 1800. Right tail test. We want to confirm whether company is claiming that increase is true or not. So mu is greater than 1800. Right tail test. The breaking strength of the cables has increased after the new technique of manufacturing process. Now level of significance 0.01 given in the problem. No need of assumption. Test statistic. Since the sample is large under HO, the test statistics is x bar minus mu divided by sigma by root n. This formula we have applied already in the first, second problems. Starting first and second problem we have applied this. So x bar is 1850, mu is 1800. Here you have written x bar 1850, mu 1800. Divided by sigma is 100 and under root n is 50 root. So 1850 minus 1800 is 50 divided by sigma 100 as it is. Now root 50 is 7.0711. So 100 divided by 7.0711, 14.142. So 3.54 is the computed value of Z, positive. Critical region. The table value of Z at 1% level for right tail test is plus 2.33. So the critical region lies for Z greater than equal to 2.33. How you got 2.33? In this diagram I'll show you. Right tail test. Right tail means the critical region is on right side. So right side, this is the critical region. This shaded area is the critical region. What is the percentage given? Alpha 0.01. 0.01 or 1% we can say. 1% or 0.01 means same. So this shaded area is 0.01. The total area under normal curve is 1. 0.5 on left side, 0.5 on right side. This left side 0.5 area, the right side area is 0.5. So 0.5 minus 0.01 is 0.49. So this area is 0.49. So we need what is the Z value for an area of 0.49. The area table, you can refer the area table. I have given the area table in the link under my description. PDF is given. The PDF of area is given. You can take a printout from there, or in any textbook or on Google, you can get this area table, Z table. So in this 0.49, so if you search the value 0.49 in the body of this table, you can get 0.4901. Exactly 0.49 you will not get. You will get 0.4901. So in which row and in which column that 0.4901 you are getting, search it. You will see 2.3. In the row 2.3, you will get 0.4901 under the column 0.03. Column is 0.03 and row is 2.3. So 2.3 plus 0.03, you will get 2.33. Here I have written. If we refer the area table, if we refer the area table Z, you find the area 0.4901 against the row 2.3 and under the column 0.03. Hence the critical value is 2.33. So we got 2.33. So this area, right? Now we have to give the decision. Compare the computed value with the critical value. Computed value is 3.54 and critical value is 2.33. So above 2.33 is the critical region. Below 2.33 is the acceptance region. This area is the acceptance region. And this shaded region is the rejection region. Shaded area is the rejection region. Now tell me this 3.54, is it below 2.33 or above 2.33? 3.54 is above 2.33. That means here we will get 3.54. So we are getting 3.54 in the rejection region. So null hypothesis is rejected. What is the null hypothesis? Mu is equal to 1800. This we reject it. Alternative hypothesis we accept. What alternative? The breaking strength of cable has increased after the new technique of manufacturing process. This will accept. Now ultimate conclusion, the company's claim that breaking strength has increased is true, is correct. The null hypothesis is rejected. We conclude the breaking strength of cable have increased after the new technique of manufacturing process. That is all. this is the end of problem number 12. So totally 12 problems. I have explained each and every problem on Z test. The next test is T test or small sample test. A sample will be called large sample if the sample size is 30 or more. So far 12 problems we have done. In all the 12 problems, the sample size was greater than 30. That's why we have applied Z test. In the next video, I am going to compare the samples, study the samples where sample size will be less than 30. In that case, Z test will not be applied, T test will be applied. That I explained. But the procedure will be similar. The steps will be similar. Laying down of hypothesis, level of significance, test statistic, critical region, decision, that will remain same. Formula will change. That will be done in the next video. So if you are satisfied with my lecture, give a like to the video, share my channel in your group, in your friend circle, so that more students can watch the video and enhance the knowledge. Give your comments on these videos and don't forget to subscribe my channel. Apart from this, I have started a new channel by name Hans Accounting Institute. You can go to the search, type the words Hans Accounting Institute, you will get my videos. That second channel I have started for IGCSE students, the students those who are pursuing the Cambridge and Edexcel Pearson courses. For them, for international students, it will be better. For other students, they can also watch the video to enhance the knowledge, to get international education in that second channel. And do subscribe my second channel also. Remember, the name is Hans Accounting Institute, and the link of the second channel is also given in the description now in this video. Inshallah, we'll continue the next topic, problems on T test, in the next video.